Our topic today is prompt implementation on different AI platforms for forensic statistics. In response to comments following our previous video, we are going to present a real world example of the application of the instructions we previously gave concerning prompt construction. I am Professor Khalid Khan from Granada, where I was distinguished investigator at the university there. To discuss the topic with me, I have my friend and colleague Moaz. Moaz, could you please introduce yourself?
Hi everyone, this is Muaz Magd from Cairo University Hospitals, and I'm happy to do another video with you, Dr. Khalid.
All right, thank you. So, in this video, you will see a prompt for a real world example, the implementation of this prompt in different AI models, and the different performance of the different AI models between themselves, plus comparison of their performance with that of human performance. To set the scene, we have selected an article published in a journal of an American scientific association. The publisher is Springer, and the article is retracted in 2025. It was published in 2016. The Grimm test, which we will use in this presentation, was published in 2016, the same year. ChatGPT became available just 4 years ago. The PubPeer comment concerning the application of the Grimm test in this paper was posted in 2024, and a year later, this paper was retracted in response to that analysis carried out by a human. In this year, we are going to present the AI analysis. By the way, before retraction, this paper had been cited 63 times, and here you see the citation graph, including 2 times following its retraction. Here is the human analysis that you see taken from PubPeer, posted in 2024 in October, and the editorial retraction in December 2025, nearly after 1 year. And obviously, it thanks Matt for identifying the error according to the Grimm test, which led to this retraction. The journey
Okay.
from suspicion to retraction took quite some time, and the test used was the Grimm test, as I mentioned just a moment ago. And Moaz, can you run us through the previous instructions that we gave in our previous video quickly?
So we previously talked about how to prompt engineer your prompt, and we talked about the PICO framework that you have to give your AI model a persona, an input format, a chain of thought, and output scheme. And this is how what we briefly explained in the previous video, and we will implement these values and these instruction to make our own prompt to use the Gram test on this same paper and see how our results will differ or agree with math's results.
Okay, so Moaz, would you kindly take us through the construction of the prompt, which is
So
the step
the
zero?
construction it will have different multiple steps. The step zero is to always check the assumptions of every test before you use it. One of these main assumptions is that this gram test depends on integer scored items only. It does not work with continuous scales. The denominator or the sample size should be less than 100, because with larger numbers it's almost impossible to find any gram inconsistent finding. A third assumption would be that the mean that we are checking is computed from raw item scores. It should not be a combination of multiple scores. That would also ruin the gram test. And a fourth assumption would be the decimal places. We have to have at least 2 decimal places to apply the gram test for it to be accurate, which is also works with every publication and every journal instructions.
So, one of the first tasks that the AI model has to do is to ensure that these assumptions have not been violated. And we are going to check that as we report our findings.
Exactly. This is how the prompt would look like. We're not going to go through the details, but we will provide you with the full prompt to apply it yourself in the comment section. And for the second step, this is how the prompt for extraction would look like. And for the second step, the next step would how the grim test would look like. Here we can see the persona that could give this the test, the actual steps in the equation that the AI model gonna use, and how to report its output or its results. And the final summary report, we have some instructions for it to look like a readable report, and you will see how it looks like in the next few slides.
Okay, so here we see a general analysis of the performance of AI tools. And for this video, we are going to take three of these top performing models and demonstrate to you what AI achieves when the GRIM test is applied for forensic statistics. So the gold
Okay.
standard will be the analysis undertaken and reported by Matt. Can you summarize this, Moaz?
Well, Matt reported in 2024 that he found four grim violations or bad values, simply saying. Three of them was on the quality of life score. One of them was on a score called the trauma scale. So we tried to replicate these findings using our prompt and the same paper and Gemini. And we found the following findings. Gemini found only one bad value out of the four values that Matt reported. And it also found one additional bad value that Matt did not report, which is interesting. And we will talk about this later. The second is cloud. Cloud found that AI support cloud. We use the cloud haiku model. This is the simplest cloud model, and it found one bad value out of the four values that Matt reported, and one additional value on a scale called the big depression inventory scale.
So the two additional bad values found, one by Gemini and one by Cloud, were two different variables or were they the same?
They were one of them was on the same variable, the the trauma scale. The other one was on a different scale that we will say explain later.
What were the
Uh,
observations according to the second attempt carried out
okay,
in Cloud?
so we did a second attempt of cloud because we found only one bad value. So let's try again. And if we when we tried again with Cloud Haiku, the simplest model, we found the same results as Gemini. We found one bad value and one additional bad value. Next, we tried to use a more advanced model. We use the Cloud Sonnet model. It's a more advanced model than the Haiku model. And we tried to replicate these findings. We found three bad values, one reported by Matt, and two bad values, one reported by the one reported by Cloud Haiku and the one reported by Gemini.
All right. So here we discover an additional feature that was not previously discovered, neither by human analysis nor by the previous two prompts.
Yes, exactly. Cloud could identify a problem in reporting of the same variable in the text and the table and highlighted that problem. The same value was reported differently in the text and the table.
Okay. And here we proceed now to the world's favorite ChatGPT.
Well, ChatGPT performance was less than optimal. It found only one bad value, the one reported by Matt. So we asked ChatGPT to retry again and try and find something else with the same prompt and the same paper. And in the second attempt, it found only the same values of Gemini. One bad value that Matt reported and the other that Gemini found. So what went wrong? Why did different AI models produce different forensics? Okay, this mainly based on how much tokens it took and the table format or the input format that you provide to these AI models. The table
So,
format was not the optimal
so
table format. It
basically,
was
the AI is not always able to read the tables as reported in published papers.
yeah, it does not always able to read the tables as published in papers. Its performs better with tables that are standardized like Excel or JSON files. Otherwise, it would need a more advanced model or more tokens or currency to do right analysis.
Okay, so your conclusion or our conclusion is that Gemini was the best of the three freely available options. Uh,
Interestingly, yes.
okay, but none of them were perfect when compared to the gold standard of the human analysis. Can you comment
Yeah,
on
and
this?
this is an interesting point to highlight because is Matt's findings the better ones, or our finding or AI findings is better? When we did double check the analysis, we found that AI did outperform the human analysis by finding that the quality of life values that Matt found inconvenient or bad are actually not legible for Graham test. They violated some of the assumptions of the Graham test. They were not based on they were not based on a mean of raw values. It was based on a mean summarized from four domains. So this is not legible for the Graham test. So this is one of the strong points of AI, that it can um, holistically understand the paper maybe even better than humans and at a faster pace. And it can also found values that we did not recognize. Even as myself, I did not recognize that there was difference between the text and the table. So that's an interesting finding.
Okay, so how do we conclude for our audience?
Well, if you want to use AI tools for forensic statistics, you should use them first as exploratory analysis. You should not depend on them as your final analysis. You should ensure that all AI findings undergo human verification by you or by an expert. You should prefer using AI advanced models that gives you better analysis of complicated forms of inputs and more tokens or currency to do whatever you want. And you should, of course, validate your findings with using multiple AI models if you can and have the ability to do so. So if you want the practical workflow for how to do how to use AI in forensic statistics, first you could start by uploading the paper, or preferably use copy and paste that uses less tokens and allows you to do more analysis. You should, after you finish the analysis using your favorite AI chatbot, you should apply it on multiple chatbots, preferably with advanced models, and compare their final results. You can even compare the final results of each AI chatbot using another AI tool, interestingly. And you can also, at the end, verify the final flagged results manually using available tools, either on R or Python, or some of the available online tools. And finally, you should document your concerns. You could either document your concerns on PubPeer, which is available and free for everyone, or you should send your comments to the editor of that paper or that journal. And what the journal does is that they conduct their own investigation using their own experts and statistical forensics, and identify if your concerns are legitimate or not. And this is the end. The end product would be either issuing a concern or retracting the paper, or saying that you simply did not do the analysis right. And finally, you can continue, Dr. Khalid.
We have a comment from a colleague in the previous video, and we would like to acknowledge and thank the colleague for the comment that we now show you on the screen. Moaz, would you like to make a response on the video concerning this?
Yeah, the final steps of our workflow is that you should develop yourself and your tools continuously. This could be achieved by not only by yourself, but your community and your friends and your colleagues. And comments like this one, which explains to us that you can convert a complicated PDF to a more simple form using a tool called Markdown, using a tool, yeah, Markdown. This is a tool that allows you to convert PDF files into a Markdown format, which is easier for AI to digest and use. So we wouldn't know this tool without this comment.
All right. Thank you all very much. And we look forward to further comments concerning this developing series on AI for forensic statistics. Thank you, Moaz.
Yeah, thank you, Professor Khalid, and thank you for all your viewers. I'm happy to come. Okay.